Welcome back to Cloud Computing and Big Data. Today we have a very practical lecture 11.1, which actually connects nicely to our conceptual lecture 11 that we had the last time. If you remember, that was given by Shadi Barakat about data mining techniques like FP Gross and association rule mining. Today we extend that a little bit. We go into some practical details, how you do this in different cloud environments. And then also we'll look a little bit into recommender techniques. Who has used recommender techniques before? You probably all use them or were a user of it. When you go to Amazon, lots of recommender engines behind it, right? Popular, what's also other people buy. This is what we will review today and why, of course, big data matters there and cloud computing is relevant. But before we basically go into the material, as usual, we will review a little bit what we basically had the last time. And the last time was really an introduction into different association rule mining algorithms, some key technique in data mining, where we basically have the idea of having lots of retail data sets and the purchase behavior of the customers understood. So basically, we remember there was this very famous idea of having this diapers and beer, right? It's actually the idea comes from UK. If you know a bit about UK people, they always go to the pub, right, to drink a beer. But if you have a baby, you can't do that anymore. That's why it is in the association rules very strong, a pattern behavior. If you buy diapers, then you buy beer. So this is a very specific example and a sort of toy teaching example. But if you go now to lots of these transactions, as purchases done, shopping carts, as they sometimes are also called, you can really understand lots of different behavior in the customers. And needless to say, this is not yet really personalized, right? So they're even personalized ones. And when we go today into the recommender engine, we see a little bit more what that means in terms of more concrete and accurate recommendations. But here you see we just have an idea of a product. Oops, sorry, we have just an idea of a product, basically of a shopping transaction, and that's it. There's no customer relationship, just a basket and different IDs or names basically for different products. Also, the amount of products we have seen basically in Shadi's presentation is a bit neglected sometimes. So it doesn't matter to say if you buy milk, you buy a hell of a lot of bread. That's not directly what we do. We'd rather say if you buy milk, then you probably also buy bread. So of course, there are more and more advanced algorithms on this. What we have shown the last time in Shadi's examples, where really we see a priori a very, very simple algorithm to do this. We had this interesting item sets, if you remember, which were stronger and stronger in counting, but then also going to triples, right? Not only to basically the double and triples and could even do more item sets, which makes, of course, then a more strong association. The problem is when you looked how a priori was created, it was not ready for big data, right? It had basically a big one-hot encoding. We go into this again. And what the solution for this was yet another algorithm that is based on a tree structure. And you will find in computer science a lot of these, let's say, modus operandi, that you basically go from a bit matrix rather to something which is a tree, because then you basically go from O to N to the 2 or power of 2, often actually to something which is logarithmic in scale. So much better basically in performance. And we have seen here a little bit then in Shadi's presentation, the different basically behavior, especially if you think about big data, number of transactions that you see below, right? You basically, with the FP Grows, have a sort of course, more time to process all these transactions, but it's not going off with a massive tail off here like a priori, which probably very quickly breaks your system because it's not working anymore. Hence, the FP Grows seems to be rather basically the algorithm of choice. And both of them you will also use in your assignment 3. Just play around a little bit. You see here support of 0.5. This is a so-called hyperparameter you can steer, you can play with. And there's no guarantee that support 0.5 is necessarily the one you want. So this is something what shop owners usually tweak, and several others which we have also seen basically in Shadi's presentation. Interesting other idea of how to do basically data mining based on deep learning was basically the idea of the pictures, if you remember. We had the interesting research project with Shadi, where basically we was working with Parfümerie Pieper. I don't know, some Germans at least know this, Parfümerie Pieper. I know it's very famous, 180 stores in Germany. No, okay. It's more maybe in the West and in the North, but they had the problem that sometimes customers come in their shop and say, hey, I want the thing that I have seen in the marketing and it looks like a gold bar. And then, you know, this is sometimes obvious, of course, it's why I do it as an obvious example, but they have no idea that it's Paco Rabanne or something like this, right? So basically what we have done is to use deep learning networks to give automatically tags in their database how these perfume bottles look like. And the funny situation is what also Shadi have shown is that there are lots of them which have interesting sizes. You have seen here the red wine cantier, the teddy bear, right, Dos Monchino, or a crystal, which for some of them is a cocktail shaker. So that what also was Shadi shown, of course, not everything is a perfect, let's say, one-to-one relationship. So some people see here actually a red wine decantier because they basically often drink red wine perhaps, but others see more like a vase for flowers or whatever. So you see this in these different probabilities below here. I know it's a bit little the text, but it's just a reflection of the last lecture, right? So this is basically also there. And by doing this deep learning pre-trained on ImageNet, on images which are for general purpose, there you basically on top of it can then train it particularly for perfume bottles as we did, and then have a little bit an association in the database for people, because now the people can search and see, okay, a perfume that is actually looking like a cocktail shaker, because some people think it's personalized more like a crystal, so we don't have any, but indeed then cocktail shaker comes back at this interesting bottle. So it's a very interesting application of deep learning that you learned in lecture 6 and lecture 6.1, which requires also massive data, which was the ImageNet database shown by Shadi firstly, and then also the trained data set on top of it, of course, then based on the perfume bottles. So very interesting use case, connecting a lot of lectures again from the past and also connecting them as real life use cases. It was a research project for 3 years in Germany. So today we cannot connect again to this, but we just have seen in more conceptual style, particularly in the first part where it was about association rule mining. Hence today I will not go again in all the explanation how a priori works, how basically FP growth works and so on, but rather the idea how you use it now in clouds, what could be obstacles. When you think about libraries we were actually using MLXtend, if you remember. And then thinking a little bit about, in the next step, what could be recommender system? So that would be the first part. Obviously, recommender is a very deep topic. I could have 2, 3, 4 lectures on it. And there are also famous companies we work with Econda, for instance, or a recommender engine company. So this is something where it is very broad, but we keep it here to one particular example that you also basically perhaps can good relate to, a movie, basically recommender. And this would we look a little bit in detail how that works. But of course, here also the idea with the assignment based on it is that you do that yourself a little bit, go to the Google Colab and do this kind of exercise with it. Then in the second part, as I said, also, as we have data mining application, I would like to connect it a little bit to the CRISP-DM, right? This process model again, so that you get more and more in the rhythm how you would actually face a real data mining problem, like Shadi did, for instance, in the store. Hello. So let's start with some data techniques on data mining in the cloud. As I said, I will do this now a little bit more, let's say, interactive. We will use the Jupyter system. The Jupyter system is what you already know from the very beginning, I hope, that I demonstrated in JSC. If you remember, we had the idea of looking at some digits at that point in time, which we wanted to use actually with the kind of deep learning later. So if you basically have here this JSC Jupyter installation, what we see here is a HDF cloud, the Helmholtz Data Federation Cloud, because the Jülich Supercomputing Center is part of the Helmholtz Association, and they have also a cloud. So I prepared here already a Jupyter lab, basically, and we have to start this up. This takes a bit of time, so I can maybe go a little bit back to the slides, and everything which I now show and actually how you have to use it yourself is described in assignment 3, right? So it's no point in making too detailed notes. Everything is well described, and I will explain it in the 3rd course hours. So more for you to see now is how it practically works, which obstacles are there, for instance, with the kernel and so on. So And basically the first step you have to do is when you go to this page is to register, right? So I'm already registered, but you have to go to UDOR, and basically with this registration, you automatically come to this. You will get an email of account registration. It will not take as long as we have seen in AWS SageMaker. I hope by now everybody has an account here in the room. Yeah, that worked. Okay, good. So this will be very straks, as we would say in Iceland. And then basically you just write here a little bit about student in class and joinable. Again, everything is described in the assignment. So let's see if that comes along. Yep. Yeah, there it is. I think the bandwidth here is meant sometimes a problem. Okay, but it's coming. So basically you see here the notebook as we left it. If you remember in lecture, the very beginning, basically we had some ideas of NumPy and things like that to you demonstrated. We had this pre-processing of the digits. By now you know how to do it with deep learning. By now you know that the 2D actually matters, that we can have information about this in the convolutions from the CNN. Today we're going to use something else, but before we actually can use association rule mining, and also the Jupyter notebooks are already uploaded for you, so you also don't have to, copy paste this from slides or so. It's all uploaded in the assignment 3. But before we go into this, let us look what we need. Here's always this ML extend, as we basically also Shadi was alluding to in lecture 11 already, if you remember. Hence, one of the first thing is when you go to these cloud environments, you have to check if all of your libraries is really, there, if they are basically those libraries you really need. So hence in your import statements, you have to check, is there something which is maybe not so standard, which in our case, apparently thinking about NumPy, pretty standard, pandas, pretty standard, as we had very early in the course. But ML extend is really a very specific package for frequent, item sets and association rule mining and so on. Hence, chances are it's not there. What the possibility is there, what I want to demonstrate is that you basically can, install the package yourself with a command called pip. We used pip already in the beginning of the course, but here we can use it again to think about the ML extend package. And usually you can never break something, right? When you use pip install, it's a bit small here today. Sorry for that. It's better when you have the PDF, but you can use pip install ML extend and use here this SSH basically on the lower level. In order to get this launcher, I just say new launcher and terminal, right? And then you get to this interesting SSH that you see here. And here you can now install your own software. If it's already installed, that's why I said you cannot break something, then it will simply say, well, it's already there, or it will update the new version, or as you see here, it's already satisfied. So this is already installed. No wonder I have checked if the demo works, right? So I did this already. But if you do it, chances are it's not yet installed. So basically, this is a common theme if you go to clouds. Unfortunately, they don't have always all the packages you need. Here's another one, pip install upgrade SkyPy. So pip install -- upgrade SkyPy. Oops. There are sometimes helper packages that you also need. If you don't do this, for instance, there will be an error in one of the scripts. This is an indirect package, basically, where you probably never really think about that should be initially an error, right? So another thing where you sometimes have to think, even the imports are not enough. It could be that still some packages require a newer version for some reason in your API that you programmed against. Hence, although you're in the cloud, very high level, right? We talked about more or less software as a service now here. Jupyter Cloud, I just do this and go there and do my thing. You still have to check sometimes the lower levels on your libraries. Otherwise, you cannot do basically your job of doing perhaps the algorithms that already Shadi discussed the last time. So in your assignment, it's now important that you think about when this is all installed, right? So this should be finished first, not parallel this, parallel that. So you first install these things. When this is done, you can nicely exit it. But the first thing you should check when you go basically to this is that you also have the kernel active before you do and do shift enter and execute the cells. That's also very important because here could be another kernel in. You see here the kernel that we can use with the Jupyter environment is quite powerful. We can switch to different ones like a Python 3 kernel and so forth, but the PyDeep Learning 1.1 version has already all what we need in terms of packages available. So there's will be not a problem, but you see here now that here the kernel is connecting. In this moment, you cannot execute here. That's very important. If you do it too quickly, you open it up, change the kernel, and now do the shift enter, it will not work. Hence, in your assignment, wait until basically the kernel is idle, right? So this is an indicator, okay, the kernel has started, the kernel is available, now I can work. And that's what we do. I mean, basically, I explain a little bit what here this is, but Shadi had already good examples about the algorithms and so on. We see here a data set that is admittedly very simple for you in the assignment. The idea is not really to have here big data, but look more on the idea of how you would execute this and work with it. So, and why this could be a problem in big data. Of course, when you think about now, you would have this interesting shopping list that we have here, basically, or the shopping basket that are available here in the retail data set. Also, the retail data set is for you in Canvas, right? So you can also download it there. Once you do this, of course, there will be some unique, interesting items, something which is might be nice to explore. And this is already the data understanding part, right? That's why I'm saying the CRISP-DM matters. The first thing you usually do is you want to understand your data set a bit before you throw FP growth, before you throw association rule mining to it, right? So hence we look at the data set, take a few basically of this head. That is basically what we do here. A couple of transactions. It's not all transactions. So we look at some uniqueness. So what are the products? Obviously, a very toy example. Think again, a supermarket, right? Which had maybe around 5,000 to 6,000 products if it's a small supermarket. If it's a large one like Costco or so, you can imagine this is going even broader. Hence, we need really cloud computing. We need basically the computing capacity, even if it's just for the memory. And the memory is here key point when you think about that everything is a very large matrix, right? From the transaction point of view, how many products you basically bought, a big table, so to speak, that basically then would be not really processable otherwise. Parts of what I discuss here are, of course, already documented here, basically on the slides. So I skip that for a moment so that we don't lose a point here in demonstrating this, what Shadi already actually described a little bit. Now, when you think about the idea how that is now put into an algorithm, it wouldn't really work because you have a more mathematical formulation, if you remember about this association rule mining. Hence, we transform that usually in something we call one-hot encoding. That's also what Shadi mentioned. So instead of having a table with real names and stuff like this, you rather have all the products as a matrix times the transactions and always do a 0 or 1 when it's basically appearing or not appearing. Again, think about what we do here now is unfortunately losing a bit the connection of saying I bought 5 eggs, I bought 10 milk, right? It's just bought or not bought. So we lose some information if you want, which other algorithms can better catch. But still, the idea is here now think about this one-hot encoding that you have a very huge matrix. Needless to say, if you think about now scalability to big data, you would have, let's say, 10,000 products. You have a 10,000 by whatever transactions row matrix, which could be quickly running, out of your memory. Hence, again, motivating the cloud a little bit. Now, when you think about the frequent item sets, as Shadi was presenting last time, there are lots of configuration options like the minimum support it should have. That is a kind of hyperparameter you really have to tune with the shop owner when you basically do this in practice. The cool thing is it really works. It's a very simple algorithm. You see with a couple of lines, we can help shop owners, right? Of just say, with this little bit of code, you at the cashier will have an iPad and say, basically at the cash in front, you say, every time there's, let's say, milk, then you basically show, hey, we have also bagels, and then you get basically the cross-selling on. Very simple idea, but can you implement directly tomorrow, right? All you need is a retail data from the end of store, and then you can go off, make your money. However, as I said, it takes a little bit of time, not really only the processing time here, but more rather the fine-tuning of these parameters. I think at the end, Shadi explained them a little bit more. There's lift, there's confidence, there's several others that you also have to look at. Hence, when you do this in the assignment, play around a little bit with this kind of hyperparameter. I will describe it later in the assignment 3, basically rules as well. And when you do this, you basically count the support, how often appearing, and so on. You then have this frequent item sets, as Shadi was explaining last time. Now we want to get us out of these frequent item sets and all of them, the combination of saying what are now the rules based on it. And unfortunately, many of these rules will be not really useful. Some of them will be kind of that the shop owner knows them by heart already. So here it will be lots of rules, and usually there is also good to have a certain threshold set, because otherwise you get tons of rules which are not really helpful in practice, right? So hence, when you play around with it, you will see it. There are lots of rules. But here we can now quickly go through and see a little bit how that works by seeing what's mostly bought together. And we see here very high support, for instance, in this rule, with a relatively high confidence as well. So people that bought bagel also will buy bread. And there you have your recommendation, milk and cheese. Cheese and milk is obvious, basically. Basically, there's a different rule set, and you can, of course, extend this to more. That had 7, this is just the first, 7 of these rules, and then the assignment should look a little bit more deeper into it and, look into it. Also, the idea is, of course, making you not perfect experts in association rule mining, right? It's not a machine learning course. It's just a basically interesting, nice application that you immediately can execute and use in practice. However, important is, again, the kernel, right? Don't forget that, please, when you do this. It's a frequently asked questions. It doesn't work because the kernel is not really working. You have to wait until it's idle. And by then, we can move to the next algorithm, which Shadi also was explaining is kind of needed because this a priori is very simple, very easy to understand, very easy to develop. Obviously, you see a couple of lines of Python code, but it doesn't scale very much. Chances are, by the good computers that we have today, that you can go to N1 downtown and maybe use just this fuel station retail customer data, and you can come out with some interesting good rules. And some of them, they will already know that this and this is already bought together, right? Shop owners have already a feeling often, or clerks or whoever is in the shop. The point is here that some are in this triple item set, so that humans not really think about these corners anymore, right? When it's about one to the other, that's often known, but when it's suddenly 2 others recommend 1 or 2 others, then it's already something which we don't have in the brain anymore so easily. Hence, we need an algorithm that scales the FP growth. We have seen the plots by Shadi's presentation. This works a bit differently, and I thought also I show you here a little bit different aspects, what you can do, especially when you try out several algorithms. The same modus operandi, if you be here, make sure you switch to the right kernel, that the kernel is idle before you even start. And basically we see here, okay, the ML extend, we have this already installed, so we assume that should be there. And let me just here remove everything because I tried it out before, just to check if it works. You can here clear all outputs. And as the kernel is running, we can now do Shift Enter. We import our basically elements we need. Also here, no basically surprises. Interestingly here, I thought it's also good to show you the data set that you created yourself, right? It doesn't have to be always retail data sets. You can create some of them for yourself and maybe edit it if you like in the assignment, play around with it with these kind of data sets. And that's in the end, it's just a simple transaction again, when you think about buying here milk and so on, this onions and etc., etc. Now, this algorithm works a bit different, as also Shadi was alluding to. So here we have then now the transaction encoder again, with this interesting idea of this encoding, which then uses a tree structure inherently to get a much better scalability, right? So I think Shadi had a couple of examples on it. So I skipped this here, and we rather focus on executing this in the cloud for your assignment. So it has a specific transaction encoder that we're going to use to transform the data set. That's actually something we also can here use then in the Panda data frame. And yeah, show you a couple of columns here for how the data frame now look on. look at, which is nothing else that you see actually beyond or above here, right? With all the different corn, the elements now basically saying yes or no, was in the basket, was not in the basket. But it's all transactions on the left. And then you basically say yes and no, yes and no. That's what we also had in the association rule mining. But now, as you remember how the tree now is generated with FP growth, also here we have, of course, the different idea of including or excluding several items. So the minimum support also plays a role here, but in a different fashion. And when you don't basically execute it, the kind of tree structure will be created inherently in this algorithm and now is able to scale much higher. So this is kind of an important factor if you are in clouds. Make sure that you have the right algorithms that scale. Also here, we have to still think about one thing. It's still not a complete parallel implementation of FP growth, right? If you want to now scale up very much to say you need lots of computing power, you want to use many CPUs and so on, basically go across nodes like we did in deep learning. This algorithm is also not ready for it. So you need a parallel implementation of FP growth to make that ready, which is in some of the, let's say, machine learning packages available to really scale up as this algorithm is doing. Right, so also this is part of your assignment to play around with it, to better understand what is now the role of the support as Shadi was explaining it. Let us review a little bit what we just had and then connect it a little bit to the next topic, which is on recommender techniques. So in machine learning, basically we have this interesting idea of learning some specific part. And many of you know this now. This was basically the coefficients in the regression very early on, if you remember. We see kind of stochastic gradient descent optimizing this. Then later we had the neurons and their connections, right? The weights that have been between all the different layers, between all the different neurons. All these weights we have learned. So learning is an interesting term. Now in data mining, you would say there is not this learnable part, but it's also not really true. And this would be now an example we're alluding to with the recommender engines that, of course, data mining could include also learning. We will learn embedded features of users and products like movies. So in a way, you have also learning here. Still, I mean, as I was alluding to in very early in the course, there are overlaps where you would say the community is not completely clear to say, well, this is now a machine learning algorithm because it has a learnable entity, right? Let's be what we will see soon. Then on the other hand, people will say, well, data mining, that's a clear topic for data mining recommenders. So basically whatever we do, it's data mining because we look in transaction we had before, but we do the same in machine learning. Hence, I mean, long story short, lots of overlaps in these communities. And my suggestion is if you go to discussions with some on conferences or so, don't waste too much time on it. Just accept the fact that statistics and signal processing, they all have these overlaps, which we nowadays call actually data science. So it's a good exit strategy. If you talk with someone, yeah, we can agree we are all data science, and then I think usually we'll all agree these days, right? It's a nice new term which was coined for these parts. Now, the interesting thing for us is that, of course, this is nowadays more blended for computing. As we have more and more higher data sets, sampling out of this retail so is unnecessary. It's only if you have maybe, let's say, bad data sets where, let's say, stupid or wrong transactions are recorded. In former times, people have sampled out transactions or so, right? And then said this is a representative part of basically all of them, like 1/10, and then computed it. That's not necessary today because we have the cloud and this big data. So this is, of course, something to think about, that in this sense, we are much more accurate. However, still, of course, think about the data quality, as also Shadi was alluding to, before he could even start with his PPA data, recommendations, association rules there, and so on. We had to clean the database significantly. There were like rabat, buttons, there were lots of interesting things like probes. You remember the kind of parfumry stores have always probes. They were encoded as products and incredibly often bought, but of course they're not bought, they just give out as a gift, but they were documented as a product. So you have to find out these things. That's why it's usually not in data science that you just throw an algorithm on the data. That's why I also want to motivate again the crisp DM, right? Why is that so important? I talked to you earlier, the crisp DM is a process where you really have data understanding first before you go further. Other, of course, libraries for basically data mining, machine learning, is k-means clustering. We had this very briefly. You would say there's the DB-scan clustering as well, advanced algorithms. And these are the algorithms where you would say, this is also on the boundary of saying, well, is that machine learning? No, in a way not, because what you really learn is not much, right? You basically use Euclidean distance here. And by this, you basically have the kind of the median, or the mean basically always moved a bit, but you don't really learn something like weights. Still, people would say, well, it's also machine learning algorithm. K-means DB-scan. I think some people would say it's pure data mining, but again, I think we should be open-minded and do it as a data science method. And you can go on and go on. There are many different others. The ones that I want to do today with you and also in the assignment is something called collaborative filtering. So we have to talk a little bit about recommendation engines. So what you do when you go to Amazon, you say, these people bought also that. It's not always just association rule mining, FP growth. It's rather also something where you think about interesting dependencies, where you have another person doing something, and keeping the identity of the person or learning the person might be quite useful, right? So what we had before were basically something, some people that did bread, they also bought milk, some people. And here we go now in the area more of thinking other people that are similar like me bought milk. So what do these people then also buy what I could buy because they're similar to me? So this is something which is much more personalized. We go to personal recommendation engines, right? They look into your specific shopping behavior and don't have a model for all of them. They basically create specific model personalized. That's why also the recommendations usually are getting better and better and better. You see this a little bit here in the example of the movies. You would say that you have two person or more that actually, all the customers, right, that actually rating movies. You have a rating scheme here from 1 to 5. So 1, let's say, very bad movie, 5, very good movie. And then, of course, you have IDs, transactions, what you have looked here in the movies. Hence, you have always this kind of unique custom ID, movie ID scheme that you connect and then give a rating. Now, you remember also my statistical learning theory beginning, this interesting diagram where I said, well, we want to learn a function, which would be essentially this. It would be a function of some sort, having this rating combined then of this custom ID and movie ID. But we have learned I could look the movie again a couple of years later, right? And then suddenly the rating would be not so good as I did. Hence, you have 2 times the X in and different Y's out, which was bad. That was this thing that we had in the learning diagram. That's where we call it rather because of, for instance, schemes in these recommendation engines, something like more a probability distribution around it, right? Another example to a lecture we had before. Now, in the end, what you come up with is essentially then this large matrix. Here, basically for simplicity, we don't have the timestamp, right? So indeed, this is more or less unique here that the specific customer had rated a specific movie. So here we kind of have not this timestamp that you maybe looked this movie twice, that you rated it differently at some other point in time, et cetera, et cetera. So basically you can say it's variably updated if you rate it new. Hence, still you come in to the idea that there's lots of movies, obviously, and then lots of users, and you can come up with a rating matrix, right? Now, this rating matrix is, of course, a very, very interesting one in many ways in one. So basically, firstly, you see, interestingly enough, which users might look which movie, right? So this is pretty obvious. So, and the holes obviously are here already an indicator, right? You could see, for instance, these users have all looked this particular movie. Why has this user not looked this movie? If there's such a popular movie, maybe Titanic, who has looked Titanic? Almost everyone today, probably. So one example of these movies, right, which basically everybody looks, no matter if you are into these dramas or not, you have to see that. It's kind of, you know, something you have to see. For this, it's interesting. But now think about going one step further, right? You could also now with this matrix think about where are the users that rated previous transaction or previous movies similar than me, right? Again, if you think about user maybe 3 and 4, right? You would say they seem to rate very, close to each other, right? They basically have green, cool movie, cool movie 3 already, which agree on the rating. Of course, simplified here, but still possible. If you now combine this user 5 and say with user 1, that might be not so good, or user 2 in the extreme scale, completely different personality, it seems, right? Hated the first one, and so on and so on. So basically, you can come to the idea of seeing, can we learn users which are similar to me, how I rated movies? And then I focus my recommendation not on the wholes of saying that's popular. I focus on those where the similarity to another user says, well, if you look this, why you didn't look that, right? Especially, of course, when you think they rated it highly. And this is something which you could, for instance, see in the idea of user 3 a little bit, right? User 4 and 5 loved this movie, really good. They agreed already on another movie. And now chances are the recommendation engine would pick this whole, because these users seem to be closer to each other. And for this, it would be not recommended because these two, user 1 and 2, are actually much more farther off. Hence, very powerful. And it's, of course, just one part of this whole idea of how you do collaborative filtering, how you do recommendation systems. As I said, it's 4 university lectures or so, usually in the machine learning course. But very interesting material. What we will focus on is matrix factorization, which is quite interesting, where we basically use this then for looking into the different ideas how people have rated movies, and where you see again the similarity is quite interesting. To learn the similarity means I have to have something to learn, right? So I learn the user somehow. And of course, this is much better. This is basically a summary what I already was basically talking about. So let's go to the idea of the different algorithms out there. So you have some memory-based approach ones, the model-based approach ones, and you see you can even do neural net these days. Matrix factorization we focus on. And here is basically the advantage for us, again, for cloud computing. That is basically something which is really, works. Dimensionality reduction is performed, where you basically then, the results are not really, explainable, but we will see with the embedded features. We will learn, for instance, in our example, later in the second part of the course today, where we basically can have really interesting learning behavior on a person. The problem is the person embedded feature will say 0.2. It's not really what you understand, but it comes to the point to recreate the rating matrix with the personalities and with the movies that we have. Hence, big topic. I cannot cover all of that, but as you see, the people always rate differently, but of course, some of them actually have a common behavior basically in doing this. And with this, you have a very nice idea how this could basically form a much better recommendation than just looking at all the shopping data. And we have an automation, which is quite nice. So we will learn an algorithm in the second part, which can automate the process. So you don't have to look at all the users. One example how you can do is a surprise package, just to show you again something here. I don't do a demo today on this, basically, but it's the same modus operandi. You have to check if surprise is there, installed. If not, you do pip install surprise package, and you have a very nice implementation in Python, a couple of lines, and you have a very nice recommender. So another example, how quickly you can come to really nice, let's say, solutions. Fast AI is another one, which I also would recommend to look in these days. Of course, deep learning techniques, which means GPUs are more or less required for this package, while other packages live maybe still on a CPU space. So there's lots of dynamics in this. Today, of course, many people would go towards deep learning. Just before we close, as a reminder for what happens in the second part, we will go again stepwise through this different process, this ChrisDM process. As I said here and summarize a little bit, you have seen before we even go and doing this important modeling, evaluation, the learning, the data mining, we firstly think about what we want to do, recommending what data is there, how we encode it, right? One-hot encoding, etc., etc. And then I come to the modeling, like, is it basically FP gross? Is it association rule mining? Is it a recommender system? Then I do this. So basically you have to first have really these steps. And once you do this, you do the evaluation and put it in the shop when you're happy. Otherwise, you have to do the circle more or less again. That's it for the first part. We will do the demonstration of the recommender then in the second part after a short break.